So, let's talk about your future boss, who might just be a robot. Sounds a bit like science fiction, doesn't it? But it raises a huge question. If an AI is making big decisions, what rules does it even follow? Well, it turns out it might need its very own constitution. And today, we're going to find out why that's not just a cool idea, but an absolutely necessary one. Now, before we get into boardrooms and high-stakes finance, let's ground this whole idea in something we can all picture. Let's talk about robot cars. It's actually the perfect way to get a handle on this whole challenge of keeping autonomous systems safe. I mean, this is the big one, isn't it? How on earth do we make a self-driving car safe enough to trust on our crazy, unpredictable roads? You might think the answer is super complicated, but it's actually surprisingly simple.
We don't just, let them drive anywhere and cross our fingers. No way. The key, the absolute foundation of their safety, is that we define their limits. We fence them in, so to speak.
And this whole idea has an official kind of nerdy name. It's called the Operational Design Domain, or ODD for short. Think of it like a very, very strict job description for the car. It says, you can drive yourself safely, but only under these exact conditions. So maybe on a sunny day, on a highway we've already mapped out. It does not mean it's safe to drive in a blizzard downtown. That's outside its ODD. This rulebook is everything.
Okay, so we have this idea of a safety rulebook for cars. Makes sense. But what happens when we take that same concept and apply it somewhere, somewhere you would never expect? We're talking about the corporate boardroom.
Yeah, I'm not kidding. Imagine taking that same safety challenge from the road and dropping it right into a company's board of directors. An AI helping to make massive, company-altering decisions. Suddenly, the stakes get a whole lot higher, right?
So the first question you're probably asking is, well, wait a minute. Why can't the AI just follow the same law as humans do? We've got tons of corporate law, just, upload it to the AI. Problem solved? Not quite. The issue is that humans and AI read the rulebook in completely different ways. And this is the absolute crux of the problem. Human decisions and our laws are what you might call social constructions. They're built on nuance, on context, on gray areas. They can handle ambiguity. But algorithmic decisions, they are technical constructions. They're all about math. They demand precision. An AI doesn't understand a vague concept like act in the company's best interest. It needs cold, hard math and logic.
So what do you do when you have one system that speaks in nuance and another that only speaks in numbers? You can't use the same rulebook. The proposed solution is pretty genius, actually. You give them two different sets of rules.
And this isn't some brand new idea. The famous mathematician Stephen Wolfram talked about this ages ago. He called it computational law. The idea that contracts and rules could literally become code, something a computer can understand and execute directly. And that's exactly the direction we're heading.
So the best way to picture this is to think of a bilingual contract. You've probably seen them for international deals. One document, but with the text in English on one side and, say, Mandarin on the other. It's one agreement, but written in two languages so everyone's on the same page. That's the solution here. Except the two languages aren't English and Mandarin. They're human speak and machine speak.
So here's how it would work. You'd have your normal corporate policy for the humans on the board, written in plain English, talking about ethics, fairness, all that stuff. And then, right alongside it, you'd have a second policy, just for the AI. This one wouldn't have any flowery language. It would be pure, precise computational instructions. Use these specific data sources. Run this exact statistical test. Do not exceed this risk parameter. No room for interpretation.
All right, so that's the big idea. But let's get concrete. What does this AI constitution actually look like when the rubber meets the road? Let's see it in action. Okay, check this out. Let's take a core principle like fair shareholder treatment. A human director approaches that with, their ethical judgment and sense of fairness, but the AI, its rulebook says run these specific non-discrimination tests and this statistical risk analysis. See the difference? Or how about monitoring management? The humans might do quarterly reviews. The AI is tasked with continuous, real-time data monitoring. It turns these fuzzy, high-level concepts into concrete, measurable tasks. This is its OD, its safe operating zone, for the boardroom. So let's pull back for a second. When you really think about it, this whole conversation boils down to a huge choice we're facing about how we want to live with AI. And there's a really powerful metaphor that sums it all up. Take a look at these numbers. It's kind of shocking when you see it laid out like this, right? The risk of dying in a car is way, way higher than on a train or an airplane. But why? I mean, planes and trains are incredibly powerful, complex machines. So what makes them so much safer?
The answer is one simple, powerful concept: dedicated infrastructure. Trains have train tracks, airplanes have flight corridors and air traffic control. They exist in a bubble, a controlled, predictable, highly managed system. Cars, they're out there on the public roads dealing with all the chaos and unpredictability of, well, us.
And that right there is the big takeaway. The whole argument is that a powerful AI, especially one sitting on a company's board, isn't like a car. It's like a high-speed train. And you wouldn't just let a bullet train drive down the highway, right? You build it special tracks. That's what an AI constitution is. It's the dedicated train tracks for AI, a safe, defined, computational environment for it to run in.
So that's really the question we're all left with. As we build this feature alongside AI, what are we trying to create? Are we trying to make AIs that can somehow navigate the messy, unpredictable public roads of human society? Or should we be focusing our energy on building dedicated, safe, specialized train tracks for them? Because the answer to that question, well, that's going to shape everything that comes next.